Last session for today. I'm really looking forward to this one as well. I hope to go through with you a little bit of just how to think about alignment again in the industry. And then we'll see concrete examples of uptake of the VSS in new areas within the software over the air metrics as well as insurance. So it should be a great session. I hope you feel that the same. So let's get right into it. First of all, the alignment track. Basically, that's how we define the activities that are involved in the conversations that are necessary to really bring the CVII goals to fruition. And that is, again, to repeat them, to establish an industry common data model, way of describing all vehicle-related data, and then several reusing and non-overlapping standard catalogs of named data items. And so that's about the outreach to the vehicle industry organizations that I've mentioned several times today, and I keep repeating it because this is really the foundation for our success in the future. We need to compare the different methods of describing data insofar as there are different alternatives and find the right requirements. And we find perhaps a collection of interrelated ways and call that collection our agreement on how to handle data. And so in order to reach the right solution and the right answer, we need to have that conversation open. And that's what the alignment track is for. I mentioned before conversations with ISO extended vehicle and related areas. This is a great great track I think we have, and the conversations with other technology alliances in order to build this together. AUTOSAR has been brought up in questions. It always is. It's a tremendously important technology organization, and we need to work together to find that alignment across AUTOSAR systems as well as non-AUTOSAR systems in order to build the complete vehicle to cloud that we all need. And so that's what we're here for, to tie all of that together. There are Sensorists. We've had conversations with Sensorists about their data catalog, as well as the way that they describe data and transfer data in their specifications. And there's a bit more to do before we are fully aligned, but I'm very, very positive towards finding that alignment as well, and bringing all the great work that has been done in Sensorists into some kind of consistency with everything else we're working on. So looking forward to that as well. And then there are other topic-specific organizations. So let's move on and let's talk a little bit about maybe a challenge here, reframing our thinking a little bit. So do you find that you sometimes think in this manner, let's be future safe. It's a little unsure what's going to be the right technology. And as long as we design for the union of all of these things that we see out there, then our customers will feel secure when we present our solution and we say we can work with anything and everything and we're fine. I think this is a fairly common way of thinking, perhaps on the supplier side, for example. Another trend we see is what I like to call the beauty contest. And that's basically when you bring in a number of suppliers or technologies and you say, we're going to evaluate these, we're going to compare them, and we really have to get this right. So let's compare and select carefully inside of our company so that we take the right decision, perhaps compared to other companies. Now, I think this is when it comes to fundamental technology like this, when it comes to the non-differentiating parts and these things that I think, hopefully, we're all convinced that we need to solve in order to really be able to benefit the full data-driven future. When it comes to those things, the beauty contest is not the right approach. And so I think you should recognize that when it happens, because it's a very, very fundamental part of the automotive industry and something we're very used to and something we often fall back on, and try to recognize when that happens. Finally, are you only consuming the diverse technologies and thinking it's up to you to make sense of them? A lot of times this could be an individual engineer saying, I can design a better solution or some kind of internal model of data that can use VSS and some other choice. So just visualizing that here. This is a scenario that we come across sometimes. People are thinking, well, there's VSS. I mean, definitely something that is being established and being adopted widely. But there's perhaps some other ideas as well on how to do things. So let's create our internal data model so that it supports both. Now, just working on that a little bit more on kind of let's put a few questions out here just to check if we can define the scenario a bit better. So first question would be if you're on board with the CVII goal, as I asked before, establishing this common data model. And if the answer is yes, then great, let's do it. If the answer is no, and you feel this is not really something in your interest, that's fine too. All the more power to you. But that's sort of where our conversation ends. Second question, have you investigated the alignment opportunities between perhaps VSS and something else? Now, this is a hypothetical. I mean, we see the uptake of VSS, but this is of course a possibility that you're considering. There is something else out there that isn't quite supported by VSS at the moment. And so the last question would be, does it really add some fundamental features? And all those also required in order to build what we need to build. Now, if you answered yes to these questions, in particular, maybe one and three, then please reframe your thinking and understand that this yellow box that you're building is the answer to the common data model. This is the model that includes all of the requirements that we need, because that was question 3. We established that above, that this is the very definition in some sense of the data model that could be the common data model. So if you see yourself working sort of in these type of thinking, try to maybe a suggestion to reframe your thinking and bring all of that expertise that you have in order to really get this done. So with that said, I'm going to hand over to Mark. Mark Singer is first, and I'm looking forward very much to see the next 2 presentations. Thank you.
Thank you, Gunnar. And welcome everyone. I'm Mark Singer. I head the marketing work group of the Easync Alliance. And we have a joint liaison agreement and have been working with the CVII team. And I would like to present to you the material about what we have undertaken and where we stand in that process. So our presentation is titled Applying the VSS Formats to Gather OTA Update Metrics in eSync. And to go through this material, I would like to start by providing you with a brief introduction to eSync and the Easync Alliance so that you'll understand who we are and what we are describing here. Then to describe to you the liaison relationship between the Easync Alliance and the Genevieve organization, or Covisa now. And then dig in a little bit deeper into the use case of eSync OTA metrics in the VSS format and walk you through that. And then if we have time at the end, perhaps open up for questions and discussion. The Easync Alliance is an open trade association. It is a multi-company initiative to standardize OTA updates and diagnostics. It's our goal to build a bidirectional data pipeline from the cloud to the edge devices in the vehicle And to build that pipeline with standard features and functions and standard interfaces so that it is an interoperable specification. The alliance was formed by 5 founding companies and remained at 5 companies until the publication of our first specification, our version 1 specification. And then after that point began growing. And so we now continue forward. We released our version 2.0 specification in March of this year. And we continue to move forward with the growth of eSync as a platform and the eSync Alliance. The eSync pipeline, as I mentioned, is built as a bidirectional data pipeline. Uh, it is from the cloud, not just to the vehicle, but to the edge devices in the vehicle. And it is intended to provide a secure pipeline all the way to the edge devices. It provides complete infrastructure for OTA updating of the software in those devices, but it also provides not only the data push, but the data pull to carry data from those devices to the cloud. Within the specifications, eSync is defined as a server client agent architecture. The server in the cloud, typically one client in the vehicle, and agents for the edge devices. And it is a distributed agent architecture. So while in the diagram we show one agent for the sake of ease of presentation, typically we would see many agents distributed throughout the vehicle. And through the eSync specifications, these different components of the architecture can be interoperable. And so it is very much the goal and operating model of the eSync Alliance that different vendors can provide their own implementations of server, client, or agent, and that these should work together. The eSync platform is agnostic of cloud infrastructure. It is agnostic of the operating system of the device, and it is agnostic of the payload. But that does not mean we don't have an interest in data formatting. We very much do, and so we'll see a little bit more about that as we go forward. eSync is not just a theoretical model; it is in production. There are 6 automakers worldwide that are building vehicles with eSync, and at this point, some 13 or 14 million vehicles committed to production with the eSync platform. And these automakers being based in Europe, China, and Japan. So it is effectively a global standard. The eSync ecosystem is part of the reason that we are here at this event and that we have our liaison. We do recognize that whatever we may have direct control over in how we build eSync, there are more participants in the process. So we have cybersecurity and vehicle regulation as a part of our ecosystem. We have cloud service providers as a part of our ecosystem. We have fleet and device management vendors and providers and consumers as a part of our ecosystem. We have the third-party hosted content delivery as a part of our ecosystem. We envision the architecting of the in-vehicle environment as a part of our ecosystem. And we envision partnerships and projects with other associations within the industry as a part of our ecosystem. Liaison projects work directly with the OEMs, work directly with the tier ones, and building our proof of concepts and our demonstrators. This is all a part of our ecosystem. And in support of that, we do have some tools available, most notably the Easync Agent SDK. This is a downloadable software platform with very simple hardware setup and installation to provide a working OTA platform. The Easync SDK is available to all members of the Easync Alliance Technical Working Group at a free of cost basis. It provides a functional Easync server account, a template agent that can be used to customize to edge devices, and extensive documentation for bringing up the OTA process, for writing agents, for provisioning security keys, and for making a complete working OTA system. And this serves as the starting point for some of our liaison activities, as it provides nearly an out-of-the-box OTA pipeline to reach edge devices that may be of interest in development. So that's a little bit about eSync and the eSync Alliance. I'd like to now turn attention to the liaison. We announced that the two organizations would begin working together in April of this year. And I've actually included here words directly out of the liaison agreement. Exhibit A on work areas, the initial focus, the CVII initiative, and eSync specifications for data gathering, with a goal to develop the APIs for an automotive industry standard for a common data model or common data service catalog. And the activities may include joint technical discussions and demonstrator and proof of concept projects. And it's always encouraging to me to see that the wording that goes into an agreement, which is often predictive of where we would like to go, to see that turn out to be, in fact, the roadmap that is followed and implemented. And this is very much as the liaison has developed. So early in the discussions, as the joint liaison working team was formed, we focused in on the VSS initiative, the vehicle signal specification, and its efforts to standardize the in-vehicle data format, and sought where this could be applied for a practical working solution. Now, there's a lot of different data sources within the vehicle environment, and there's much diversity there. The data that's generated by a backup camera or a LiDAR or radar system is very different than the data that's generated by an ABS controller, which is again very different than the data that might be present in an infotainment system, a head unit, or even a digital audio amplifier. So the first question to be addressed would be, what data do we want to focus on? And what was sought was some universal data for a first use case, universally applicable data. And this drove us to the actual OTA update metrics, because in all of those cases, a sensor, an ABS controller, a head unit, in all of those cases, if they are in the eSync pipeline, we will be doing updates to them. And so we will have correspondence and data opportunities between the server and the client, within the client, between the client and the agents, within the agents, and between the agents and the edge devices. And this all then provides opportunity for applying the VSS model. So let's take a look now in a little bit more detail into the use case of eSync OTA metrics in the VSS format. Beginning with kind of the difference between a lab environment versus actual automotive OTA. It's relatively easy in a lab environment to measure how much time it takes to update a device because you connect to the device and you do the updates. But there are many factors in OTA in the automotive arena in deployed vehicles, many factors that affect OTA performance. At the server, you have the process of signing, of uploading, storing, creating campaigns, deploying those campaigns, and then monitoring the updates. The client in the vehicle takes some period of time to download updates, to manage any service interruptions, loss of signal, corrupted data, to verify those updates, to check policies of the campaign as to when the process should be implemented, and to transfer those updates to the agents. The agents then have metrics of performance on the decryption of the update. This material will be sent encrypted. In the review of policies, different devices in the vehicle may have different policies about when they will actually update their software. Then, only then, you get to the actual programming of the device with the update. And then in the real world, you also have occasional failures in the updating process that may dictate the need for retries. And you would want to have data on those events, as well as on the process of rolling back in the event of retries generating failure as well. So all of these are factors that will affect the overall performance of an OTA platform in the real world. So examples of the metrics, the authentication and connection time, the type of network connections. So this is a piece of data that will be important to understanding and correlating and improving performance, is to know whether, in the case of a given vehicle, the connection was over 4G or 5G or a localized network, the speed of the network link, the signal strength, the type of cloud. Did we have a content delivery network involved? Did we have, if this was 5G, is this coming through an SEM? Um, the payload size, the download times, the retry connections, all of this information uh, is important metrics to be used for improving performance. And then within the vehicle, we have the secure hash verification times, the encryption and decryption times, the in-vehicle network type and speed. So reaching different edge devices may take place over different buses or networks. Ethernet for some devices, CAN for many more, LIN for some devices, FlexRay, or even most in some cases. The payload size, the time taken to check policies, the transfer times, the delta reconstruction. In many cases in OTA, we're not sending a full image, we are sending a delta file. And in those cases, the client or the agent will actually be reconstructing the image before it is flashed, and the rollback retries. All of this will be the kinds of metrics that we want to measure to improve the overall performance. To do this, we build a proof of concept, a working practical use case. And so this is the undertaking of the joint working group at this point. Much of this work taking place jointly, some of this work taking place among the Easync Alliance members. Um, we're standardizing the in-vehicle data type, describing in YAML, and as an indicator of the progress, we anticipate the named types and the definitions to be submitted to the repository by the end of this month. So we are actually making good progress on this now. The platform has 3 real-world edge devices to be included, with some diversity of device to help us ensure that we're touching on real-world use cases. We will be using ECUs provided by different members of the Easync Alliance, a body control module from Hella, an airbag controller from ZF, and a head unit from Alps Alpine. The agents for these devices are being adapted to make use of a VSS library, to encapsulate the OTA metrics in the VSS format, to compress and encrypt those formatted data, and to send them to the eSync client for the eSync client to push to the eSync server. And then at the level of the server, to make use of that data, to make that data, to bring it to a usable format, that will involve parsing the VSS formatted data, storing that data in a database, and implementing a visualization, a dashboard, to visualize that OTA metric data, so that inferencing and decision can be drawn on the overall performance of the OTA platform. And I'll pause here on this diagram just for a few more moments so that we can understand a little bit about the work being done in building this pipeline to actually send updates to these devices and then measure the performance of the OTA process and draw that data back up to the cloud so that we can visualize that data, and from that process learn the real world performance of the OTA data pipeline and build towards improving that pipeline for the performance in general. So with that, we have a little bit more information on our progress. We anticipate, we've already begun gathering data from the platform. We anticipate completion of the POC within this year, which I mentioned at the beginning. I had the marketing work group of the Easync Alliance. That brings us the interesting opportunity that this may be available in time for consideration, even for public display at the beginning of the year, the beginning of the new year. With that, we're completed, and if we still have time, perhaps we can take some questions.
Yeah, I think we'll take all questions at the end, Mark. We'll collect them while Neil is presenting, and then we can deal with all the questions at the end. Thanks so much, Mark. Cool stuff. And if you want to ask questions, put them in the chat box. You go to the menu on the left, the top icon, and then select the main stage chat. You can write your questions there on any topic. The alignment track that I spoke of, the presentation from Mark, or the upcoming one from Neil. And so with that, I'd like to present Neil Walker joining us to talk about really cool innovations in the area of insurance and how it relates to standard data. Welcome, Neil.
Thank you, Gunnar. And thank you. Thanks for having me here talking about insurance and the impact of VSS and connected car, connected vehicle on insurance and the insurance sector. I'm here to talk or briefly give an overview of how the alliance between insurance and VSS is helping support what I call the decentralization of insurance. We've seen some great sessions today that have talked about distributed computing, event-driven architectures, microservice architectures. But in essence, it is about the decentralization and decoupling of core business logic and insurance and motor industry and the connected car and VSS are all closely interlinked. So this session is around my role within an organization that I work with in the UK called Conveyor Insurance. I am the head of architecture and responsible for the technology strategy for a insurance service platform. But I also work very closely with Gunnar and Geneva as a member of the Open Insurance Initiative. I've been working with the Open Insurance Initiative for over the last 6 to 12 months, and I lead the Open Insurance Mobility Group, whereby an open community from both Geneva insurers come together and look at data standards, data alignments, but also look at how we can establish and move to a connected solution to support insurance organizations and insurtech organizations, working closely with OEMs and VSS standards and telematic standards to look at how can we better improve the customer experience and drive out an open insurance data standard for the motor sector. And I'm here today to talk a little bit more around that, my progress with that. That's a picture of me and my son, just to show a bit of familiarity. I've been working within technology over the last 25 years, a variety of different areas, but data and cloud and event architectures and microservices are what I work very heavily with right now. Before I get into some of the specifics, I wanted to start by talking with the why and why we're here, or why insurance industry is here. But I do think it touches on some key themes we've heard today. I've had some great talks today around the Netflix model, event streaming. In essence, there is a key change in how distributed computing and the connected nature of all of our lives are now coming together, and that's opened up new possibilities, which is why we need to work together on unification of standards that help drive some of those initiatives that Gunnar was touching on, why bringing VSS and other data standards and getting to that opportunity of aligning different areas together. And I see that's very much how insurance is moving towards, certainly in the motor sector. It's opened up greater customer experiences and new opportunities. My role within the Open Insurance Initiative and the mobility group is to take us to a place where we can start to realize some of those opportunities. So just very simply to pull this together and how we ended up in a decentralized technology strategy. You could go back many years ago where traditionally we had one system, one machine, but everybody worked off that one technology platform, that one technology system, whether that was large mainframe systems that served multitude of organizations. And over time, we've started to move to single systems with additional machines. But the reverse has now started to happen as we get into a decentralized environment where we've got distributed systems, distributed machines, all responsible and working directly with one person, whether that's yourself if you're driving a car, from an insurance perspective if you're a car driver, if you have pets and you have pet insurance, if you own a commercial fleet business and you have a fleet of cars that you're responsible for, if you have your own business and business insurance, we've got a number of different systems, interfaces, machines, all distributed on different networks and different nodes interconnected together. So the responsibility of those transactions is no longer centralized. And this is the opportunity of the interconnectedness that it will bring, and also the demand to have a standard that supports those opportunities in a safe, secure, and meaningful way. So that's why we've ended on a decentralized approach as we become more distributed and sensors and signals become more verbose and more enriched. But from an insurance perspective, who does this impact the most? Ultimately, it's all about the customer and knowing the context where a customer is in. From an insurance perspective, and certainly in a motor perspective, our customer market is changing dramatically, whereby you may undertake insurance for an annual period. People will want insurance to work and think differently, and the work done with VSS and the work we've done in insurance is presenting a great opportunity to start to drive some of the new needs for our customers who ultimately are very demanding. They want it immediately, they want it automatically, they want to use services that we provide how they choose, where they choose, and any device on their timetable, whenever they are, and however they want to interact with them. They don't want to feel constrained. to a given device or interface, the customer experience and the customer context is critical to get insight from the data that we are working to align with VSS and with open insurance and the mobility. So it's important that we understand the customer context and the meaningfulness around that data. So what does that mean we're doing from a VSS and open insurance? Well, we need to focus on real business outcomes and real insurance business outcomes, but it's also about opening up alignment in this track around how do we align the insurance industry with a vehicle specification to present a better customer context, a better customer experience, one which customers are asking for in our markets today. So how we've been working this through to date with VSS and open insurance, we've been collaborating on open opportunities. We currently have a version 1 of an open insurance mobility standard published, which is accessible on openinsurance.io, that myself and a number of colleagues in the Open Insurance Initiative have collaborated on. That describes an API standard and a data standard at a domain level approach that we've taken. One of the reasons we decided to work through a domain-driven design model is to focus on those agile architectures that are decoupled and decentralized, so we can deposit and physically implement systems of record or systems of function or innovation on any node in different devices. So this may be cloud-based, it could be in-car based, dependent on the nature of the system and the complexity of it. And today in that open insurance mobility design, we have covered the concepts of real-time policy, claims, cover and payments, supporting event-driven architectures, where we are focusing on car events for vehicle domain-based real-time signals, augmenting the insurance and underwriting decision. So the more enriched the decision we can understand about the driver or the vehicle or the car, the better the experience we can offer the customer. And we are also focused on real-time events that we can then consume and actually support some of the decisions we need to make in an insurance environment, and some of those standards and scenarios I'll touch on in the slides coming up. But taking a domain-driven design approach, it allows us to segment and support different areas of insurance, but also reference and align with a vehicle standard that we can support in an open and mutually beneficial manner. So progress to date that we've been working through in the mobility group with Genevieve, working very closely with Gunnar and the team, is looking at how do we reference different trees of information within an insurance domain model and within a VSS domain model. And where we are currently at the moment is that we are looking at an insurance product model that has the potential of sitting within the VSS specification. This would help drive out an open insurance market for insurtechs and insurance organizations to share in a manner the status of an individual motor insurance, or indeed others that would have other forms of insurance that would support the experience for that customer context. But likewise, sharing the vehicle domain knowledge with insurance organizations, we can calculate and price insurance policies and in a real-time manner react to claims for customers to support them at a time when they need their insurance, to support them in any event, that we can help them and be more understanding of their needs. So we're currently at a place where right now we're aligning our data standards. We're exploring what it would mean to embed a motor insurance product within the VSS specification to address things like premium for policies, cover that the driver or the vehicle may have, potential status of a claim, all manner of insurance processing that we can embed within the VSS standard and adopt, closes this insurance data initiative on an open platform with the VSS initiative, and brings together two sectors to work together for ultimately the customer and the value to the customer. But it does beg the question, how is insurance changing, and how is the connected car changing, and how could insurance actually become part of an OEM or a given vehicle's behavior to support the driver, to support the passengers within the vehicle? All of which are very exciting opportunities that we are starting to explore. And how we're going about doing that is we're also working with tools collaboratively in an agile way. We have defined 20 to 25 different use cases that we want to elaborate and POC. That very soon we'll be publicizing a document working with Genevieve, VSS, and the Open Insurance Data Standard to invite insurance organizations and OEMs to contribute on a proof of concept to elaborate the use case scenarios and the data standards to evaluate their effectiveness. Some of the standards that we are looking at, some of the business processing we are considering that I've touched on around commercial fleet, but also things like reward-based insurance. A goal is that we do not want people to ideally crash cars or have cars that are actually broken into to support their experience. Can we influence driving behavior in terms of alerting the vehicle that the insurance organization has noted you're parking in a high risk zone? You may not wish to park here. It could actually drive a significant impact to your insurance policy. To obvious scenarios, that can we work with OEMs on the signals that will let the insurance organization know that safety features were deployed in the car at the time of an impact. This would also help things like claims processing, because that will allow the customer to get quickly through to payment and quickly through to support to either repair their car or indeed get the driver and the passengers to the right level of healthcare that they need. So there's a tremendous amount of opportunity here by bringing these standards and the data sets together. Excuse me. Some of the mechanisms by which, certainly within an insurance organization, is that it's not just about aligning on the vehicle. And I did want to add this slide in to talk a bit about the connected world and the nature of how insurance organizations are moving to a more distributed and decentralized understanding of their customers. Is that it's not just about insurance for the motor. We're also working with and understand how does this mean for the connected nature of your devices, for your home products. It's very similar insurance processing model where ultimately we price based on the risk that you are operating in as much as a driver may operate in. And we do that by in certainly within my role within CVII, the insurance organization that I work for in the UK, we implement microservice architectures that support real-time event data streaming that also will feed into insight for MI and business insight, but also building a data lake platform that supports microservices that conduct certain scenarios and calculate the likelihood of a risk occurring, or provide support to customers to prevent something occurring, whether that's not just about car or motor, but it could be potentially about fraudulent scenarios that a customer may be experiencing. So all of these scenarios we're plugging into in an insurance organization into one single platform to support the decentralization and distribution of insurance data, but also to support the connected nature of standards through VSS to better inform the insurance product premium and price that we wish to offer our customers. So there's a tremendous opportunities to build an alliance between two standards and drive fresh and new opportunities, both from a vehicle or an OEM manufacturer point of view that would like to offer insurance and work with their customers in an insurance layer, as much as insurance organizations that can offer the best price and customer experience and ultimately prevent the nature of scenarios that could occur that impact the customer. One scenario that we are looking at that's particularly of interest is how we can drive open standards if we were facing a multi-crash scenario whereby we might have a number of vehicles that were engaged in an event and we very quickly needed to understand both from the signals that are exhibited for the vehicles and the insurance policies that the drivers or the car itself may be attributed to help us understand the best nature to respond. These scenarios are obviously critical and have huge impact to people's lives, which is why it's all about understanding the customer context. Currently within the Open Insurance Initiative, our approach through the standard development is we are currently working through an engagement, validation and assessment phase before releasing and publicizing standards. We are targeting to publish updates to our invitations to conduct proof of concepts, which will have reference to both VSS and Open Insurance to show an alignment in how we're working together and how we can both augment and adopt standards, both from an insurance vehicle domain or from a VSS insurance product domain to help encourage people to participate and work through some of the scenarios we have finalized and we're publicizing over the course of Q3 and Q4 this year. So finally, before the last couple of slides, to just talk, it's critical to talk about the how and what and guidance that I'd like to pass on around what we must consider when we are engaging on proof of concepts and what it means to provide appropriate abstraction and to give a bit of advice to those working excuse me, both in insurance or in the mobility areas. There's a lot of insurance organizations face a significant amount of technical debt. The sort of technical platforms and architectures that exist are not malleable to the type of event-driven designs and microservice environments that we'd wish to leverage in a highly connected real-time environment. So this is a significant challenge. How do we leverage systems of record, adopt the right standards, but achieve these real-time interfaces for our customers? Well, we do need to look at alternative systems that support real-time data integration, distributed security and compliance. Apologies, I've got some formatting issues on the slide, but some of the features of those new systems must support continuous delivery. So the nature of which we can support idea to production of a POC or of a platform is critical. It is ultimately about how do we embed events and microservices in a technical platform that allows real-time change, or I would just better describe it technically as a DevOps capability. What mechanism do we deploy to support a distributed security for configurable context for a customer? I do envisage some customers that may wish to or may not wish to engage in the level of openness that we provide, but it's about ultimately making the technology adaptive and avoiding tightly coupled systems. We must build technology that is aware of context but supports standards. By that, sharing the data is critical, but by rapidly understanding the insight the information provides is the purpose. And ultimately, testing experiences, not systems, is critical. And this is fundamentally about consumer or driver behavior. When we are assessing and evaluating POCs, technically, we must focus on the experience that we wish to test and evaluate, not only the technology system itself. Otherwise, the opportunity can well be missed. So some of the key challenges that we're working through right now is the service-oriented nature of domain and business-driven design to support customer employee behaviors. It takes quite a bit of an analysis and design, which is why we bring insurance professionals together within the Open Insurance Initiative and VSS and Genevieve and Telematic SMEs into the conversation and work through the data alignment and the possibilities behind the standard. Focusing on discrete products, build out and prove and iterate is key. It's quite easy to look at the bigger picture and the strategy, but ultimately we'll learn more by focusing on real value early rather than significant investment that comes, by the time we get this right technically, it's almost the opportunity will have gone. And then how do we break down monolithic systems, support real-time data sharing contracts? What does that mean in a smart contract scenario? Could an insurance product live within the vehicle itself and inform the driver on their behavior as a driver, inform the driver on how they are aligning within their policy, support the experience for the customer so they're aware that their policy has been renewed or their claim has been paid in real time. And finally, the business model for those machine events and real-time insurance is usually dependent on aligning our standards to open up the market to support this, combining rapid release. So a good example, one principle I advocate in my role is that we release twice daily to production systems and we test and learn as rapidly as possible, but to not underestimate the employee and the customer's mindset. We must test behavior and not only the system. And finally, just to wrap things up, the goal being when we move to a decentralized place, we move to many systems and many machines, all providing an experience for one person, rather than that centralized single large monolithic platform serving many people quite often in a way that is not personalized for those individuals. So the insurance agent in our own organization, it's answering the phone to the driver. The insurance agent, it's looking at the driver behavior and looking at the premium we'd offer the customer. The insurance agent who's looking at a claim for a driver and updating the in-car insurance product domain to inform the driver of their claim. And the insurance systems that are in the in-car systems processing the insurance claim are all existing outside of insurance organizations and now decentralized and distributed, but all handled by that one individual, that one insurance agent working with that one driver. That's the end of my session. Thank you very much. I really appreciate the opportunity to come and speak at the conference, specifically coming from an insurance perspective and from an open insurance perspective. I think some fantastic opportunities to bring both these standards together to open up new markets and innovations. So thank you very much, Gunnar.
Well, thank you, Neil. That concludes our technical session today. So we don't have any questions in the chat as of yet, so we may just wrap up. And as I said before, there is the opportunity to head over to the CVII meeting area. I'm told it's also known as the meeting area 5, which should be on the right side of the stage, I believe. So I will stick around there for a while if you want to head over there and ask questions, and I'm sure I will be joined by some other speakers as well today. Hope you join us tomorrow for the workshop sessions. If you go to the wall, on the wall, there's information about these. And I think you will get also some information now from an announcement coming up. So stick around for another minute and you will hear the final announcements for today. Thanks again, everyone, for joining today, and I'm signing off